Hello everyone and welcome back. I am Mr. Cobalt, and in this video today I'm going to be going over orbital diagrams and electron configurations. So in previous videos I've gone over PowerPoints where I go over penetration and electron shielding and how that leads to the sublevel splitting. And then I talked a little bit about how you're going to do your electron configurations. Now, in this video, I want to go over some examples and really clarify how you do this. And so here is your orbital diagram, and so this is the order of the different levels, sublevels, right? So each line, I know in the book and in my videos or in the PowerPoints, it talks about squares being representing your orbitals, or circles, or lines. I tend to use lines. So each line is an orbital, and they are labeled by the sublevels, right? So I have the lowest sublevel is going to be the 1s. And there's only one orbital there, so it's the 1s orbital. And then the next sublevel is the 2s, which only has one orbital. That's the 2s orbital. And then you have the sublevel 2p, which is has three orbitals: the 2x, the px, the py, pz. So this would be your 2px orbital, your 2py orbital, and your 2pz orbital, and so on and so forth. So this is the order in which the energy levels and their sublevels are ordered. So you can see that in the hydrogen atom, and let me just start with the hydrogen atom, or all one electron systems, right, where the atom only has one electron, then there would be no sublevel splitting. And the sublevel splitting is seen here by seeing the 2s and the 2p. Because the 2s has more penetrating power, the probability has a higher probability to get towards the nucleus. Then that lowers the potential energy of the orbital, of the sublevel, and then it drops it down. And so the same thing happens here. So this sublevel here is higher in energy because it does not have as much penetration power into the inner electron space. So it doesn't get as close to the nucleus. So it ends up being higher energy than the 2s. And so you can see that with the 3s, the 3p, and the 3d. Again, these are different energies because of the difference in the ability for the electron at those energies, in those sublevels, in those orbitals, to penetrate into the inner area of the electron. So the inner electrons, which I'll refer to as the core electrons, shield the nucleus from those outer electrons, which are the valence electrons. Okay, so this is in a hydrogen or a one electron system, these would all be the same energy. So the 2s would be the same energy as the 2p, and the 3s and the 3p and the 3d would all be the same energy because you don't have those inner electrons shielding the nucleus from the outer electrons, because you only have one electron in the system and you don't have those repulsive forces between the electrons, which is acting as shielding as well. So there's a shielding effect from the repulsive forces of electrons as well. Even if you only have two electrons in your atom, they're both in the same shell, so it's not like you have inner and outer electrons in that case, but you still have repulsive forces which in effect shield each other from the full effect of the nucleus. So you'll get shielding, you'll get a sublevel splitting that way as well. So most of the atoms except for hydrogen are going to have sublevel splitting. Okay, so, but keep that in mind. So anytime you have a one electron system, you don't have sublevel splitting. All of the sublevels at the same energy level, two here at the same energy level, should have the same energy. So 3, 3, and 3. If this was a one electron system, then 3s, 3p, and 3d would be at the same energy level. Okay. So that's our orbital diagram. This is for a multi-electron system because there's sublevel splitting. And so how do you go about writing the electron configuration for elements? So you got to follow three things. You have the use a different marker. You've got one is the Aufbau Principle. So when you're building up your orbital diagram, so you need to know how to do an orbital diagram because your orbital diagram is where you get your electron configuration. In another video, I'll talk about how you can use the periodic table to get your electron configuration. But you should know how to use your orbital diagram as well. So you need to know the orders. You got to memorize the orders here, and there's a trick where you can remember what the order is. But when you're building in here, when you have your orbital diagram, when you're building in the electrons, you're going to be adding them to the lowest energy levels first, and you're working your way up to higher energy levels. That's the Aufbau principle. So you always start and fill in the electrons from the lowest number, right? So you're given a certain number of electrons in your atom, whatever that atom is. You should know the number of electrons, and then you're going to fill in those electrons into the sublevels and orbitals as you go up in energy until you run out of electrons. So that's the idea. So that's the Aufbau principle. You're going to start at the lowest and work your way up to higher and higher energy levels. Okay, that's the Aufbau principle. The second principle that you are going to use is the Pauli exclusion principle. And the Pauli exclusion principle basically says that you can only have two electrons in an orbital, and they must have opposite spins. And this goes back to the fact that you can only have two electrons, can never have exactly the same four quantum numbers. They have to have at least one quantum number that's different, and that's where the opposite spins come in. And there's only two spins, so you can only have two electrons in an orbital. Otherwise, if you have more than one electron in an orbital, one of those electrons, two of those electrons are going to have the same four quantum numbers, and that can't happen. So you got to fill it in, and as you're filling in, each line is an orbital, so when you put in two electrons, they have to have opposite spins. Okay, and the third one is Hund's rule. And Hund's rule says that as you're filling electrons into your orbital diagram, when you reach orbitals that have the same energy, you have to add one electron in each orbital first, spin up, right? So I do spin up, spin up, spin up, right? So one in each orbital first. I don't pair them up right away. So I put one in each first, and then if I have extra left over, then I start pairing them up with the opposite spin. So if I have spin up, spin up, spin up, and I have extra electrons, then I'll start pairing them up. Okay, I'll put a spin down in this one, a spin down in this one, a spin down in this one, and then they're all paired. If I have leftover, then I keep going, right? And that's the same for the p orbitals, the d orbitals, and I don't have f here, but the f orbitals as well. Okay, so as long as I'm following these three rules, I should be able to get any orbital diagram, and then from the orbital diagram, I get my electron configurations. So let's start easy. Let's start with hydrogen, right? So hydrogen has only one electron. So I put the electron in here. Oops. So I'm going to write that as a half arrow. So spin up. So here, that's the orbital diagram for hydrogen. It's only got the one electron in the 1s orbital. So then from here I get the electron configuration. So I have 1s for the subshell. So I'm going to write down 1s. And then I put a superscript of a 1 because that's how many electrons I have in that subshell. So it's 1. So that is the electron configuration for hydrogen. Okay, what about helium? Helium has 2 electrons. So I put another electron in here, but it has to be spin down because I can't have 2 electrons in the same orbital with the same spin. So they're opposite spins, so I have 2 electrons in here. So that would be the orbital diagram of helium. So then from the orbital diagram, I can get the electron configuration. So in this case, it's the subshell is filled here, so it's 1s. And I have 2 electrons in that subshell. So I'm going to put a superscript 2 for the 2 electrons in that subshell. Let's keep going. What's the next one? Lithium. So lithium has 3 electrons in it. So here I have my 2 electrons. I have a third one so that I can't have more than 2 in here, so I got to put the third one in the next higher one, the next lowest energy level. Because I always want to have electrons in the lowest energy level. That's where electrons want to be because that's lowest energy is less potential energy, more stability. So everything nature wants to always go to lower energy, higher stability. Okay, so they're going to want to be in the lowest energy. So I put my third electron there. So now this is the orbital diagram for lithium. So then I write the electron configuration from the orbital diagram. So I start with 1s. I start Aufbau Principle, start low. So I have the 1s sublevel filled with 2 electrons. So it's going to be 1s, 2 electrons. And then I go to the next one, 2s. So I'm going to write 2s. And how many electrons do I have in there? I have 1 electron, so I'm going to put a 1. Okay, so here's the orbital diagram for lithium, and then here's the electron configuration for lithium. Okay, let's keep going. So what's after lithium? Lithium is going to be beryllium. Okay, beryllium has 4 electrons. Let me double check. Yeah. So beryllium has 4 electrons. And so we're going to, again, we have 1 orbital here at the 2s sublevel. So we're going to put in a 4th electron. We paired them up, opposite spins. So now we have the orbital diagram for lithium, or beryllium, sorry. And then now we're going to put those 4 electrons, we're going to write them in order. So 1s2, so we have 1s2, and then we have 2s, 2 electrons in the 2s. So 2s2. Okay, so this is the orbital diagram for beryllium, and this is the electron configuration for beryllium. So I'm going in order of the low energy to high energy, and I'm writing them in that same order. Okay, and we can keep going. We can keep going, adding electrons based on what element we're looking at. So in the next video, I will continue this, and we'll look at more examples to get a better idea of the electron configurations. I hope this was helpful so far. If you like this video, share this video, hit the notification bell. subscribe to the channel, make a comment in the comment section, and I'll see you next time. Thanks for joining me.